All right, good morning, everybody. Let's get started. This is basically officially the first lecture of Applied Science 246. The Wednesday lecture, we have used it for the recreate. So today, I'm going to officially start the lecture, but I'll go over the syllabus first, and then we'll have some lecture, okay? Because I'm recording the lecture, and also and because of the microphones, so I can't get away too far from it, and then you cannot pick my voice that's good enough. So I'll try to restrict myself close to the podium, okay, instead of walking around in the classroom. So as I said, let's go over the syllabus first and be clear with the expectations for all of you guys, what you can get out of this course, right? So that kind of information is very important. What are the evaluation grading schemes for this course? Okay. So again, welcome to this course. For some of the students who choose not to come, that's fine. So you will be able to have a chance to watch the video. And there are also some students still not able to come here yet. So that's why we're providing this sort of a hybrid mode of learning. So just a little bit myself, I think you have already known me at the different occasions. And but I guess seeing the person in the real life, this is probably the first time. So I graduated from Shandong University in 1993, a long time ago, with a Bachelor of Engineering degree in electrical engineering. I got my Master and PhD from both UBC Vancouver, actually from mechanical engineering. So I have a very mixed background of electrical and mechanical. So I do robotics, controls, mechatronics. Yes? Oh, you can't hear me? The microphone doesn't work? So let's try the handheld ones. Okay, is that better? No, let's turn. So how much do you not hear me? Anyway, this is just an introduction of myself. Okay, I joined UBCO in school engineering in 2007, almost from the beginning of UBCO school engineering. The beginning is 2005, so I joined 2007. I have really experienced the significant growth for the school engineering. Remember at the time in the room, there may be 30 students when I was teaching a third-year class. So I have taught a number of courses. Second year, 246, 248, which they are the course I'm teaching this term. I've also taught 254, third year, 380, so design machine elements. I also taught 486, 487, so they're robotics and digital control course. Okay. So as you can see, they're mostly in the mechatronics area. So I'm currently a professor teaching. The other title of me is Associate Director for Undergraduate Study. Okay, so a little bit about lecture now. Monday, Wednesday, Friday, 9 to 10. So a very good time, I think, in this classroom. So we'll be lecturing in person as long as our situation allows. Okay, we'll try our best to do the lecture in person. The university policy does say that if you get sick, including you and I, we should isolate ourselves. So there's a chance that we, or me, actually, maybe a temporary shifting online if I get sick. Okay, but it's sometimes fine, you know, I do the online. Now we also have communicate with our faculty. If somebody get really sick, then we have a backup, you know, maybe somebody else will substitute this class. So same message to you too. If you get sick, you shouldn't wear a mask and coughing in the class, so making everybody else nervous, right? So that's sort of a common sense. Now to reduce the number of interactions, we moved all of the tutorial sections to online. Okay. So tutorial, I feel They are good as a supplement to the course material, but at the same time, they are, I wouldn't say not as important as a lecture, but tutorial typically happens in a smaller classroom, so we can try to reduce as much risk as possible. Okay. Now look at this link to find out the actual tutorial schedules that you have signed up. You should sign on to one tutorial section, and I always strongly recommend that you go to the tutorial, because the questions, the material we prepare for the course in the tutorial greatly supplement the lecture content. Here's a list of the TAs, and you can find their same information in the syllabus. Okay. Your TA and the TA section. So if you have any questions regarding the tutorial or even the lectures, feel free to also ask the TA. I'm also open to all the questions too. So basically, we're a team at here to help you out to be successful in this course. So this course has a relatively larger number of TAs. We have 2 TAs for each tutorial section. So you're actually lucky. My other course is only 1 TA per tutorial section. My office is on the 4th floor, 4235. In ideal time, I always keep my doors open. You can always pop by and say hello or ask questions, and that's fine. So I maintain an open door policy. Right? Now, given the COVID, things I can still do that. As long as you wear a mask indoor, right? So I'll be fine with that. So personally, so I'm not going to be too picky. Okay? However, if you prefer to give me a 24-hour notice, send me an email to make appointments, it's even more appreciated. So that's even better. For office hour, what I intend to do, I would intend to have 1 in person, 1 online. So Monday and Wednesday temporarily set to 1 to 2 o'clock. Okay, so the Monday one, I'll try to do in person, and then Wednesday one, I'll be doing that online through Zoom. The link of this office hour for the Wednesday ones is also in the syllabus. I'm not going to post it on the campus anymore, so it's going to be a permanent. So every Wednesday, 1 to 2. Okay. Now, if I'm not there, for some reason, if I have an emergency meeting, sometimes administrative requirement, I can put up an announcement, okay? Or you can always send me an email if you don't have to wait for a long time, right? Yeah. I also highly encourage you to make use of the office hour. Okay? Strangely, even though I have like close to 200 students for this section, in the past, not many students make use of office hour. Not sure why. Maybe I'm an intimidating person, but for those who make use of office hour, now they can certainly test how much benefit they can get from office hour. Right? I think personally, the most beneficial part you come to me is that I actually can remember you. Okay? In the class, especially now with a mask on, it's hard to recognize the face. But if you come to the office hour, temporarily take off the mask, so I can remember the face. That's really one of the in-person teaching I'm really kind of always looking forward to, so that I can remember my students. Right? Not all of you guys, of course, that's too many, but I think what's most fun of is, right, somebody I can recognize their face when I'm outside UBC. Say, oh, you're my student, right? Yeah. And interesting that last year, even though we all did online, there were a couple times I was shopping outside. There were a few students just came over and said, "Are you Dr. Child?" I said, "Yeah." They said they're wearing masks, and I cannot recognize who they are at all, right? So I was wearing mask too. I said, "You're fantastic. You can recognize me with my mask on." Maybe because of the unique feature, So anyway, I think given this precious opportunity of teaching in person again, I personally wanted to know some of you, okay? Not just as a walk by teaching and that's it, right? So textbook, this course, there's no mandatory textbook, so you don't need to buy really a textbook. If you want to read any textbook, you can read that advanced engineering mathematics listed in the syllabus right here. Okay. The reality is the course content of this course is quite a mix of bags at here. So in the mathematical department, they probably just call it a differential equation. Okay, so, but in this course, we added some more component into this course. We call the system concept, and you're going to see that. So and then plus the solving differential linear equation. Right? So there's a little bit more than the typical math course. So I think my lecture notes, okay, which will be typed lecture notes, will be more than enough for most of you to be successful in this course. We'll also be providing some additional exercise, and so that should be enough historically. I haven't heard anybody saying, you know, they didn't have enough material. But of course, if you're the kind of person who wanted to grab a hard copy book, always wanted to read as a reference, so here's one. Okay, a little bit about a course policy out here. So since we're all in the classroom, so I would ask you to turn off your cell phone, and including me. This is fine if you forgot, that's okay, but just to pay attention to that. You're not supposed to do anything that's not related to this course in this classroom. But of course, if you're too sleepy, I'm not going to be too picky, that's fine. Yeah. Now this course will have a midterm, and we'll come to that shortly. Okay. So but we're not going to do any makeup for the midterm test. So if you missed the midterm for some legitimate excuse or reasons, for example, you're sick, family reasons, religious reasons, we can move your midterm weight to the final exam. Now this course does have homework, but we're not going to grade the homework. Okay, so we're going to give out the assignment and a self-study, self-practice, but we're not going to grade it. Okay, so the last bullet right here shouldn't count at all. So just ignore that. There will be about 8 to 9 set of homeworks. Okay, so solutions will be posted. Post assignment first, and then we'll post the solution maybe a week after or a few days after, right, depending on the how the term goes, okay, and also depending on schedules. I highly recommend that you do all the assignments and practice all the questions on your own, even though they're not graded. Okay. As you're going to see later, okay, this course fundamentally is a math course. So there are a lot of integrations, derivatives, you know, solving mathematical differential equations. So for math course, the best way to be successful is to practice. Okay. So if you just listen to my lecture, chances are you could understand right away, but if you don't practice and they're giving another question, I'm afraid that you won't be able to solve that in a very timely fashion. Right? So you've got to practice. You can practice on your own. You can practice in a group setting. But bottom line is, you've got to practice. Otherwise, right, you're going to get in trouble during the actual exam. I'll use the Canvas as the learning management system. Everything will be posted on Canvas. So here's a good time. Just a reminder that for this course, a little bit different from the structure of my other course. So what section I'm teaching is 101 or 102. So my section and the other instruct section has one Canvas shell. Okay, so we're keeping each Canvas shell for each section. On top of that, we have another common shell we call the tutorial shell. Okay? So you basically, for this course, for every one of you should have 2 shells that you can access. The shell that's me, which is basically called, maybe let's say 101. Okay? This is the place I will post all the lecture notes, solutions, assignments, tutorial notes, right? And videos, recorded video links. The tutorial section is a section that the TA will post the Zoom links for the tutorial, and TA maybe will post some other material, right, common to basically all students. And also, when we do the online quiz or online midterms, and that is also the shell that you can access the the exercise, the assessment. So make sure that you know which shell is which and which shell you can access what type of material. All right? Yeah. But my other course, we have just one shell now. 248 has just one shell. Now here's my channel, YouTube channel. I've been done recording video for many years. If you look into the channel, you probably actually can see some previous years 246 videos. Okay, that's fine. Things don't really matter. The good thing is math is they don't change, right? They have been very mature, so they don't change like some cutting edge technology. But I will post my recorded video to this channel, and also I'll post the video list, okay? The link to the video list on the canvas. So you click on the video list, and then you'll see all the videos for this course. So here's what you probably are most interested in, is how we will assess you for this course. So I said I'll give you assigned homework, but they're not going to be graded. Okay, so there's 0% on homework. For quiz, we have maybe 3 or 4 quizzes. So we'll do it online. Okay, so they're only about 10%. My philosophy on quiz is give you a chance to practice. So most probably, I actually will make the quiz as open book. So you have one question, and you can certainly rely on help. But I encourage you, of course, to do it without resorting to any lecture notes first, right? So give yourself an exercise. Time yourself. How much time do you need to finish this one question? So this type of question, for example, typically is expected to be 20 minutes or 30 minutes in the exam setting. Right? Now, in an open environment, when you're first doing it, it probably takes you 40 minutes. It's fine, right? But that gives you an idea how you can improve, right? Which part that you should learn, and then you get ready for the actual exam. So that's the format of the quiz. We will give you an advance notice. Say, okay, next week we're going to have a quiz, right, on this subject, and this time on this date. So we'll post that, and you can be ready. Midterm, we already tentatively set the time and date for the midterm. October 18, from 7 to 9 o'clock in the evening. So we'll give you 2 hours, right? The lecture time is 1 hour, so which is not really enough. And we also intend to do the midterm online. The reason is because we anticipate some of our students, in particular international students, due to visa problems, they couldn't join you in time. So we're giving them a little bit of buffer area here, so they can still come over for the final exam. Okay. So final exam will be firm, at least for now. Everything's scheduled to be in person. Unless this COVID getting serious, there's different orders from the provincial government, then we'll do it differently. But for now, the final exam is scheduled to be in person. Okay. So you can see the final is relatively the larger percent. The quiz and midterms, due to this, they are online. And I fully anticipate there will be some cheating behavior. Okay, now, this has happened last year, and we have dealt with some of these cases thriftily and seriously. However, as we all understand, this is not sometimes you can't deal with every cases, right? So final, we do have a policy that you have to pass 40% in order to pass this course. So if you look at the quiz and midterm, total 40%. If somebody got 90 average, for that 40% of the course, and then flunked the final with very low grades, less than 40%, and that's not convincing to me that you actually have putting your own effort in this course, right? So that's why I want you to be honest, to actually do well, to pass the course with actual personal effort, okay? So this is essentially the structure of the grading scheme. We're going to have an opportunity to address the academic integrity, but I think this is overall not from my course, right? will be honest with us. Okay. All right. So what is this course all about? Right. So every course, there's a purpose of that. The name of the course is System Dynamics. So system is a very key word, is adjective keyword, and then dynamics, right? So it's talking about dynamic, not the type of dynamics that you have learned in your first year. Similar, actually, there's some similarity, but this time it's more related to the system dynamics. So we're going to come to that. Well, what is the concept of system? Okay. Yeah. Here's a list of topics, okay, that you will see in this course. So we'll cover a linear time invariant system. So many of the key buzzwords probably sounds strange to you, but we'll come to that. Okay. And what are some of the weird functions? One of them is called impulse response function. And what's the definition of the operator, convolution? Okay. So those are all concepts going to help you understand the dynamics of a system. How do I characterize a system? Okay. Characterize system is basically means how to understand the system better. What are the inherent characteristics within a system? How do I solve ordinary differential equation? So linear ordinary differential equation is essentially a mathematical tool that you use to describe a system. Solving that is to give you deeper understanding of what's going on inside a system. Right? Actual system always more complicated than a linear ordinary something described by linear ordinary differential equation. Actual system is always nonlinear, but this is a starting point. Okay? So linear part is always a starting point. And there are a few other very important concepts, but not so much of as interesting as building an actual car or building an actual machine. For example, Laplace transform, Fourier series, Fourier transform. To be honest, this is where actually I lose a lot of our student interest or focus. Okay? So that's just a heads up. And when you see some of these concepts, it's immediate shut off. You say, "Ooh, you know, I don't like that." Yeah. But we have to try, and this is a part of the engineering education. Not everything is up to your personal interest, right? So you have to give yourself a little bit of nudge and to make sure that you actually get into that mode to understand the concept, the math. Some of the prerequisites for this course, okay, if you really want to brush upon your old knowledge, 173 is a very important prerequisite. You will do a lot of integrations, derivatives. 178, not so much. You know, we do use a little bit of DC circuits in this course, which is what you learned in 178. 180 statics and 189 dynamics, a little bit from these two courses, because there are probably a couple lectures on system modeling. So we do analyze the free body diagram. We do actually derive the system equation using Newton's second law. Calculus, mostly what's involved is differential equation and integration. Okay, so I'll do a little bit of review shortly. Okay, so we do need to use Newton's law, and we do have to understand to some extent the kinematics and equilibrium of a rigid body in 2D space. That should be enough. Some common understanding of power, energy, force, pressure, displacement, velocity, acceleration will certainly help you with this course. So why this course, right? You know, I always show you these slides here. You know, for every course, there's a purpose. Why this course? This course will provide a fundamental methods of understanding system behavior, as sort of I already alluded to. Okay? It sets a stage to your third year, which is particularly important to your electrical program and mechanical program. Okay? And I'll come to civil. For electrical, okay, you will have a deeper understanding of so-called signals and systems. And that's a very important part of your next stage of learning. You learn communication and you learn signal processing, right? So this course, pretty much what I will cover in the first month, will directly relate it to that area. The Fourier series, Fourier transform, Laplace transform, and you probably will learn again in other courses. Okay? But this is the first course that you will actually get to know those important tools. Now, signal processing, right? Now, probably not as important for mechanical civil, probably not as important as electrical. But inevitably, when I talk to industry people, right? No matter whether they're mechanical or civil, so when you raise this question, the common answer is always, yes, the student should know that, right? You're structural engineering, on the surface you probably don't feel like you need to understand signal processing concept, but someday they say you will, right? And I wouldn't say it's a must, but it's a very useful tool, skill to have, right? Knowledge to have to deal with that type of concept. So the point I wanted to raise here essentially, which is always I got the question, why do I learn this as a civil engineer? Why do I learn this as a mechanical engineer, right? I won't argue with you in a very much of a depth because, to be honest, even if I spend a day to explain things, I'm probably not going to be able to talk you into, to persuade you. Let's put it that way, right? I'd give you time. And maybe in your lifetime, you're never going to use some of these skills at all, right? But someday, you probably will use it and you start realize, oh, okay, I learned this in university. Right? So I think the point is there is a purpose behind it. So just be patient, right? And this is part of your curriculum, and there's a meaning behind it. So let's get on with it, and let's do well in this area. Okay? So let's start with a little bit a description on the system. Okay? And I already have sort of said that the course is system dynamics. So the first thing is, what exactly is a system? Right? So you'll see the buzzword, the keyword so many times in this course. Okay? System is a very large concept. You can use mathematically or structurally, you can use a black box to represent any system. System can be big, system can be small. Okay? Individual person is a system, the classroom is a system, the whole UBC is a system, the nature is a system, right? The transportation is a system. Right? So system can be applied to so many different areas. But you can always apply the system to think of the system as a black box. And a black box needs to have input, needs to have output. Okay? Sometimes you don't have to have an input, but system certainly will have output. Okay? So what that means essentially, without knowing, when you're presented with a system, you probably don't really understand the inherent mechanism, the inherent characteristics of the system. So what you can always try to do is, let's put in an input to the system, and then observe the output of the system. So you can look at the input and output, try actually to understand a little more about the system, right? So I'm using this, for example, this class as a system, an example. I have almost 200 students in this class. If I have to use a mathematical formula to describe the dynamics of the system, it's probably going to be very, very sophisticated. Right? But you may have a way to do that. Okay? Yeah. So if this is the system, then what is the input to the system? And the analogy is my teaching and some other stimulations will be the input to the system. So let's just say if the teaching is the sole input to this system. Okay? So I'm lecturing, I'm talking, right? And you listen to me. So now the dynamics start rolling, right? And you talk to your peer. Okay? There's some inherent movement among students. Okay? Is there noise? There could be, right? There's some disruptions. There's some probably unwanted, signals getting into the system, which actually will cause a problem maybe, depending on the size, depending on the significance of the noise. So that's why we call it noise. Those are disturbance. No matter what, right? Once you have an input to the system, your reaction, okay, let's put it with maybe your performance, right, will become the output of the system. So there are n number of performance from each one of you. So let's call that n number output. So for this system, I would call it a single input and multiple output system. Okay. Yeah. For a simple system, which actually what this course will deal with, is single input and single output system. Okay, that's mostly what we'll look at first. So the next question would be, how do I characterize this system? Right. So essentially, you don't want to just look at the input and output. You know, as an instructor, I might be more interested in, well, look, if I teach this way, right, this is the best results the students following. It may follow, you know, exponential outputs, a sort of relationship, right? That's exactly what, as an instructor, maybe strive to find out. Ideally, if I have a formula, y equal to 2x plus 3, that kind of formula. I put an input there, and then I got an output. Perfect, right? You know, my life is much more easier. The next day, I'll just do exactly what this formula tells me, and then I expect exactly what can get out of the system. Okay. But of course, that is not always the case. So what is the actual response then? Right? So you can see this is a very typical response if I talk about control system. So I actually forgot this course is so important if you want to get into control area, okay? Because control is all about signal processing. It's all about signal and systems. So that's particularly important to both mechanical and electrical. But nowadays, civil engineers also do a lot of controls, right? We have professors working in earthquake control of the building. So when there's earthquake, there's vibration in the building. How do I suppress the vibration in the building? You design a control system of that. Yeah. So you look at this graph here. Okay? Let's say this is a selective type of response from a student when you hear the teaching of me. So some student, given the time from the start, actually start going down, meaning not quite used to or not quite accustomed to the style of my teaching. Right? But as the time goes on, and it's like come back. Okay. Now this is if this is a standard. Okay, this is basically, let's say 100% satisfaction. Then maybe the student not reaching this 100% standard, but still we call that the student reach a steady state. Okay, so that's called output. Okay. Now some other student grades, there's no lag at all, so it's immediately going up. But unfortunately, due to whatever reason, it slowed down, and there's a little bit difference, a discrepancy between the standard and the student performance. So this is what we call, this is actually called, there's a bit of what we call a steady state error, between your performance and the standard. Okay? And this one here, the red one, okay, this red one is something I call it critical damp system. Basically, the system is not so fast, the student response not so fast, very steady though, right? Very steady. Steady, 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 steady. Finally reach this 100%. This is perfect. This is actually a lot of time I'm looking for. Okay? You don't need to, like the next one, okay? It's steady improvements, right? There's always adaptation. And the other type of students is active student, very much into this course, actively learning, but there's overshoot. Overshoot is fine, you're spending too much effort maybe, but there's up and downs, party too much, come back, okay, and then go back to the routine, right? And the student actually finally reach the same stage as the red one, right? So this is what I call system response, giving you this as a perfect. Both the yellow and the red are perfectly okay, okay? Yeah. So we will look at in details later, okay? When we look at the different ways to solve a system, get the response of a system. But this is sort of the things that you would actually expect from the responsive system. Okay. Again, this is a little bit cliche. I showed this in my other class. Okay. How do I succeed? How can I succeed in this course? Try to do the 3 things before, during class, and after the class. I can guarantee you'll be fine. If you have any particular requests for me, feel free to let me know. Okay, so this is basically the structure of this course. All right, so I have talked about how the lecture will be conducted, how the tutorial will be conducted, how the evaluation scheme, those are most important parts, will be structured for this course. And what if there's an emergency happens, right? How can I communicate with you? Okay, so those are well listed in the syllabus. And also the midterm date and time has been set. If you can set aside, if you have a working shift, you probably wanted to make some changes. Okay. Now, if you do have some other commitments, let me know. I'm not sure I can accommodate, but we can try to find a solution, right? Yeah. Any questions? All good? Yes. The recorded lectures. Yes. There might be other videos on solving some special individual questions. Yeah. Okay. Good. If there's no question, I still have about 15 minutes. Okay. So to give you just a little bit a sneak into how I conduct the lecture, I will use a OneNote, okay, to do the lecturing. And the program must be recording in the background. Yes. So now sometimes things also happen. I forgot to record. If you can actually remind me, that would be great. It's for the benefit of other students. Okay. So let's get started. So nothing really new. I'm going to just do some very quick reviews based on my past experience. Some of the pitfalls or some of these common mistakes I have seen within student exams or assignments. Okay. I did post it lecture notes on Lecture01 review on the Canvas already. Okay. So there are more topics in the lecture notes than what I will cover in the lecture, right? So if you wanted to have a fully review, just look at the lecture notes. Okay? Even bring out your past textbook. Okay, so let's talk about the concept of function first. Okay? So as you're gonna see later, we essentially use sometimes function to describe a system. So when we have a function, okay, now this is the simplest function you can have. It's called single variable function. Right? In other courses, we're learning multivariable function. Right? So the proper terminologies. This is called a dependent. The exit here is called independent. So we're all on the same page, so we should talk in using the same language. And then this f at here, okay, the f at here, what we call its operator. So basically, operator, right? As you're going to see, we're going to have so many different operators. Operator essentially is a system. It's a function type of concept. Okay. We're going to look at so-called convolution operator. A derivative is operator. Okay? A different derivative, you do a first order derivative, and that's actually an operator. Okay? You do integration, that's also an operator. In other courses, we'll have so-called greetings, curl, divergence. Those are all different kind of operators that you're going to come across. Okay? So the point here is, right, when you see a function, you can call it function f. Alternatively, you can also call it's an operator. Okay. Here's a very simple, I'm sure everybody knows, but I've seen people making mistakes. Okay. So if you have an exponential or power, okay, so e to the power of x plus y, okay, high school stuff, right, is equal to e to the power x times e to the power y, right? Yeah. And if you have a e to the power of x and then to the power of y, and what would that be? Exactly, right? So, because I have seen people making mistakes, and they write this one to be this one, okay? Or sometimes they write this one to this one, right? So there's little mixtures in their mistakes. Okay? So make sure this is a very firmly applied, and when you see these kind of operations, because you do use this quite a lot in the next few lectures. The other expectation I need you to be able to do is you need to be able to draw exponential functions and maybe also to draw some other very simple functions. Okay? I singled out exponential function in here. Draw means you actually be able to sketch that. So, for example, I give you exponential function, e to the power of negative 2t. Because we need to graphically solve some question. Okay? So what does this e to the power negative 2t graphically look like? Okay? It's not just a rough sketch, but there should be some element of accuracy in your sketch. So the way to do sketch is, okay, you have a t here, and this is e to the power negative 2t. Right? So label this properly. Okay? I've seen so many students, when they do sketch, they don't label anything at all, right? So you need to label it properly. And once you have this one here, to do graph, as you learn, you basically find some points or coordinates, and then you connect all the dots, right? You get the curve of this graph. And for me, it's very simple. You can always start from t equal to 0. When you plug a t equal to 0 here, you get 1. Okay? And then when you increase the t value, okay, when you increase the t value to a larger and larger value, and this is exponential term will become what? 0, right? But it's not gonna be 0. It's gonna approach 0 infinitely, okay, but not gonna be 0. As t goes more and more to the negative side, because it is negative, so it's gonna increase. It will increase to infinite. So basically now you can safely, this is what we call sketch here. So passing through this point and then approach this 0 value infinitely. Okay? So that's what I call roughly sketch of this exponential. We call this is exponential decay function, right? It's a very useful function. Next week, the tutorial will start, by the way, first tutorial, and you will get a chance actually to review how to draw this function based on this e to the power negative 2t. So this is very simple, right? This is what we call, this is a shifting. Okay? So you are shifting, okay? You're shifting this function that is here to the right by 1 unit. So that's what we have learned in the high school, AP Calculus or Calculus 12. So shifting means it used to be 0 at 0 it's 1. Now at t equal to 1, and you're at 1 location. So now you still have exactly the same shape of the curve, just shift to the right by 1 unit. So that's what I expect you to be able to do this. This is actually part of the first few lectures. We're going to graphically solving some problem. We're going to do shiftings up and down, left and right, and maybe even scaling. Right? Being able to draw them out will greatly help you intuitively to understand the question. So of course, I should probably say, can you also draw a straight line y equal to ax plus b? Right? If you have a line equation given, right, can you draw it properly on xy coordinate system? If you have some other simple functions like y equal to x squared or y equal to 1 over x squared, right, So some of these very simple functions, what do they look like? How do I properly draw it? Okay. So I need you to be able to do that, okay? A few more very fundamental things is derivative. Okay. So you have learned derivative in 172. If I have a function single variable, okay, now there are three ways to indicate the derivative operation. The first way is called notation. I should say notation. Is you write it as a dy over dx. Okay. This is the first order, second order. Right? You write it like this. And this notation is called Leibniz notation. So any notations I presented here will be fine with me, but you will see in my lecture notes, I rely on this one quite a lot, and also the next one. You can also write derivatives this, so f prime or f double prime, right? So this kind of notation is called Lagrange notation. Alternatively, you might write it as a y prime or y double prime, right? Yeah, it's the same thing. The last type of notation you see is y dot, y double dot. Okay, on top of this letter. What's the name of this notation? Anybody? Exactly, this is Newton's notation. Okay, good. So Newton's notation, okay, you probably also see that in my lecture notes. Okay. This is a particularly used for a function of time. Okay. So function time means if you have y equal to f of t, okay, so let's say t squared plus 2, that kind of function. Okay. So we use this Newton's notation in this kind of function because t, we use it to represent unity, okay, not just a regular variable, but also for time, right? So if you have a time function, then the derivative of that time function will give you, if this is a position, then you get the velocity. If this is velocity, then you get the acceleration, right, the derivative. So that's why this Newton's notation is particularly applied to this type of function. So I want you to be clear, we not that any one of notation is in the preference, but if you see that in my lecture notes or in my daily writing, so just don't be confused. Right? They're all mathematically the same thing. Okay. All right. Other things, and I pretty much want you to do a little bit review on yourself, is to brush upon your techniques on integrals and differentiations. All right. So what is product rule? What is quotient rule? So you need to memorize. Basically, these things should be by heart. Let me ask you, you just whip it out. That's it. Right? Without having to look into a reference book to find out the formulas for these things. Okay. U v prime, u prime v plus v prime u. That's quotient rule. That's the product rule. U over v prime, representing derivative. Then you get v u prime minus v prime u, and then over v squared. Yeah. So to be honest, every time there's students during the exam, they ask for, so what's the quotient rule again, right? To me, I seriously want you to memorize this. Okay, you don't have to ask. I think this is like a 1 + 1 = 2 kind of things, right? You need to memorize this. Now, in terms of integrals, there are a few techniques you really have to brush upon it. I don't need you to be able to very proficient in conducting very sophisticated integrals, okay? But I do expect you to know some of the integrals like by heart. Like this, 1 over u's integral, right? Ln u absolute value plus a c. If it's a 1 over u square, okay, then you get a negative 1 over u plus c. Right? And this one particularly is also important. If you have integrals like this, okay, so this is what I call substitution technique will be involved, right, for this type of integral. It's 2 theta plus 3 at here. So how you learned is you let u equal to 2 theta plus 3, okay. Then you get du equal to d 2 theta plus 3, which equal to 2 d theta, right? And then you can do substitution now. So the substitution, basically, you get, instead of a cosine 2 theta plus 3, now it's cosine u. And the d theta at here, right, the relationship here is 1/2 du. But be careful, your integral limits will change due to the substitution of variable. So how do I find the new limits for the integral limits for u? Because theta goes from a to b. And here is the u at here, so that means u goes from 2a plus 3 to 2b plus 3. Right? So now you can plug in the new limits at here, right, as the new integral after substitution. So the rest of this is very straightforward now, so then you can do the calculation. Right? Okay? However, let me finish. Oh, actually, okay, I'll stop here. I'll show how I do this in my lectures here for substitution. I typically don't follow this one here, okay? So, but I'll show you next lecture.